Hi, my name is Anuj. I'm a student of Masters of IT at ACU. My student ID is S00391346. Today I'm going to present you my assessment 3 for Python ITEC 610. So let's get started. Let me share my screen. So let's delve into it. First of all, that is my presentation for the assessment 3 talk, exploring BRFSS data. So what is BRFSS? It stands for Behavioral Risk Spectral Surveillance System, which collects data on health-related behaviors, chronic conditions, and preventive services from US citizens. So for this assignment, we have provided a data in a CSV file, and the data sets includes 414509 entries, and in which there are key variables such as age, current weight a year ago, and height. So in that data, there are some missing values, so which we'll see further. So the section one is the summary static analysis. So in this section, we analyze variables like current weight a year ago, and height. And in the data, it was labeled as weight 2 for current weight and WTYRAGO as weight a year ago and HTM3 as height. So for the methodologies that I have used for this statistics includes max, min, median, standard deviation, 25th and 75th percentiles. For the visualization and the markups over the graph, I use black triangles for max min values, blue for min median, green for mean and standard deviation, and red for quartiles, which is 25th and 75th quartile. So the key findings that we get after analyzing is that the current weight mean is 79.06 kg, standard deviation is 19.51 kg, weight a year ago, mean is equal to 79.81 kg, standard deviation is equal to 20.58 kgs, height mean is equal to 169.01 centimeters and standard deviation is 10.39 centimeters. Both weight variables exhibit significant variability, suggesting a trend of slight weight gain over the past years. And for the section 2, which is correlation analysis, we use Pearson's correlation was used in this assignment and to show the relationship between the weight change and current weight a year ago, and age. So for the weight change, it was 0.035 negligible correlation, and for weight a year ago, it was minus 0.319, which is moderate negative correlation. For the age, it was minus 0.069, which is weak negative correlation. So the result we get after analyzing is that weight a year ago has strongest association with the weight change, suggesting previous weight may predict future weight fluctuations. On visually representing these things, we get to know that minimal relationship between current weight and weight change, and there was moderate negative correlation between weight a year ago and a weight change, which suggests that prior weight influenced the weight change over time. So age has a negligible effect on weight change, which with other lifestyle factor like more influential. So in section 3, we did significant analysis. In this, a linear regression model was used for the house sizes and prices, and the key results include data set size from 15,000 to 35,000 square feet, and price was 2,50,000 to $3,90,000. So the predicted price was 2,500 square feet house, which is approximately 33 lakh. So the model captures a proportional relationship between house size and price within the same range. So in the linear regression model insights, the linear model fits well with the given data set. As house size increase, the price tend to rise proportionally, showcasing the predictive power of linear regression. However, factors such as location and amenities can affect accuracy in wild applications. So in the conclusion section, we can say that there are three key takeaways: health insights, predictive modeling, and opportunity for further analysis. The health insights include the data shows a slight trend in weight increase over the past year, and with moderate correlation between past weight and weight change. Predictive modeling, the house price prediction model illustrates how historical data can guide forecasts. Opportunities for further analysis. Future studies could include machine learning to predict health outcome based on the behavior and demographical factors. Thank you. That's all was with the PPT. Now I will show my work. Let's minimize this. Here is the collab file of the code. That's the task one, in which we have imported Panda libraries and load the data which is provided by the tutors and extract the relevant information like that I said earlier. The data was weight 2, weight WT by RAG and HTM3. So we are storing this data in current weight a year ago, and height. So for the preparing the data plot, we use columns and labels. And this from summary statistics is used to store the data in mix, mean, median, and 75 percentiles. For marking, we use markers, colors, and start labels. And proceeding with the further analysis, we get this plot. That was the task one. And in the task two, we have to do calculating correlations and know which is strongly correlated and which is not. That's why we use this functions, that the correlation method, np.coef, which is np is import numpy as np. That's why to do the correlation, we need to import numpy as np. And moving further, we use scatter plots to visualize the data. So that was our output, that we got that current weight is this value, the value of weight a year was this, and the age is this. So after analyzing, we got to know that the most correlated variable with weight change is weight a year ago, and that is this. Moving further to the task 3, in which we have important matplotlib and use SQL and linear model to import linear regressions. That was the data set that we all predefined. For the linear regression model, we use this. And for price prediction, we use this. Predicted price is equal to model.predict, and that was the value that we have to predict. And after predicting the value, I just like to show it using a plot. Plotting the results, we got this result, and that is our regression line, and the blue dots show the data points that we already have and we have to predict, and that is the prediction which is on the point. That was with the collab file. Let's delve deeper into our report, and then that's the report, which included the introduction, like the behavior risk factors outline system that I explained earlier. That's the dataset overview, that there are a number of rows 414519 and number of columns 7. The key variable analyzed are current weight a year ago, and height. Section 1, summary statistical analysis. Key methodology that is used is written over here. And for the visualization purpose, I use these marks. The dataset contains 385,974 entries, which each of the variable current weight a year ago, and height after glimpsing and missing values. Key statistics are as follow. Current weight mean is this. Standard deviation is this. 25, 50, and 75% are this. So same likewise goes with the value of weight a year ago and height. That is the comparative analysis. I made a table so that people can easily understand it. That is the comparison section. That is the most important section right now. Current weight has a slightly lower mean than a weight a year ago, suggesting a general trend of weight gain across the sample population over the past year. The height variable displays a smaller range and standard deviation compared to weight, as height generally varies less among adults. Both weight-related variables exhibit significant variability as shown there in quartile ranges. So that's all of the section 1. Now we move further to the correlation analysis, which is our section 2. So after all the performing methodologies, like this correlation between weight change and weight a year ago, current weight was valued this, weight a year ago was this, and age is this. So I have explained each and every factor with proper manner, like current weight. This is the column which indicates weak positive correlation. Weight a year ago correlation coefficient of minus 0.319, showing moderate negative correlation. I use scatter plots for the visual representation, and that is the results. From these correlation results, weight a year ago shows the strongest association with the weight change, implying that prior weight can be a moderate predictor of weight fluctuations in the population. In contrast, current weight and age have minimal correlation with weight change, highlighting the factors beyond current physical characteristics may contribute significantly to an individual weight dynamics over time. So these are the visual representation that I added into my report. Now let's dive deeper into the task 3, which was about the linear regression. These are the data sets that we provided in order to train our model. The code used for linear regression is this, and for prediction is this. So the prediction section, after fitting the model, it was used to predict the price of 2,500 square feet house. The model produced an estimated price of approximately 33 lakh for a 1,500 square feet home, aligning with observed market trends for mid-size houses and training data. A scatter plot is used for visualization and insights. So that is the result. Predicted price of for 2,500 square feet house is 3,26,000 Australian dollars. And that is our visualization of the price prediction. And now the last section, which is conclusion. We have got 3 key values: health knowledge, implementation of predictive modeling, and use of additional analysis. So according to the difference between the population current weight and weight from a year ago, the analysis of weight-related variables shows a tendency of slight weight rise over the past year. This can be an indicator for a large cultural shift in eating or lifestyle pattern. Public health initiatives may be benefits from possibility that prior body measurements could serve as predictors for further health changes, as seen by the moderate connection found between past weight and weight change. So this is the conclusion that we get after the analysis in the task 1. Implementing predictive modeling. The house price prediction model serves as an example of how predictive model may be constructed from historical data, as shown by the linear regression analysis. Even though these models have a basic structure, they serve a crucial basis for more intricate assessments, such as forecasting future economic and health measures. So these kind of models can be used for further forecasting as well. That is written in this section. Uses for additional analysis. This analysis creates opportunity for further research that I mentioned earlier. One proactive way to manage health trends would be use machine learning techniques to forecast outcome based on behavioral and demographic factors. Furthermore, investigating the connection between weight change and other health habits, such as food and physical activities, may provide deeper understanding of the variables affecting health over time. So that was all with the report. And that was our PPT. That is our report. And that is code output and explanation, in which I use code and screenshots of the output and with the explanation of each and every aspect of the code, like importing the libraries, which is used for loading data, data processing has done in which code, plotting the preparations, calculating the summary statistics. So I've clearly mentioned all the things. For task 2, that's the output of the task 2, setting up. That means starting by importing libraries, calculating the weight, data cleaning as there are some missing values in the data, calculating the correlation, and that is fun. That is the variables that are being used for the correlation. Finding the most correlated variables, max function, printing the correlations. That is start. That is the linear regression model. So I think that's it for the assessment task 3. That is the PDF. And this is our the collab note PDF. So I will stop sharing my screen now. So that's all with the assessment task 3. It was a fun task to do. And I learned so many things from this task, like how to use linear regression and how to do data cleaning. And I can say that that was really informative for me. I just want to say thank you so much for this chance. And yeah, thank you so much.